Hello, welcome to Math 103. This is the section 2.4 lecture, and in this lecture we'll be talking about some motion and angle problems, and I do have a worksheet that I've prepared here that we can work through together. So if you want to go and print that out, find that on your course website. These will be motion and angle problems. We're going to be talking about some word problems. These are going to be linear equations that we can write for these. But these do have to do with motion and distance and rate and time. And then we'll also talk about some angle problems at the end. Let's go ahead and get started then. Number one. Jerry leaves his house at 8 a.m. and travels east at 40 miles per hour. Sue, his wife, leaves the house at the same time but travels at 50 miles per hour. In how many hours will they be 350 miles apart? And then in part B, in how many minutes will they be 350 miles apart? And we're going to round to the nearest minute. All right. As far as putting the information down here, may use some pictures here in just a moment, but we're going to arrange most of the information in a table. So let me go ahead and draw one of those right here for us. And in this table we're going to, of course, have a line for Jerry and a line for Sue. And along the top, what I'm going to put is I'm going to put the rate in the first column there, and then the time in the second column, and then the distance in the third column. Want to fill in the table best I can. Now, Jerry's rate is 40 miles per hour, so let me go ahead and put that in there. Now the time, it says he leaves at 8 a.m., but actually on this column here I'm going to want not the time of day, but the amount of time traveled. So how much time did Jerry travel? Well, that's our unknown, so that's our x. We can call it x if we want to, and that's what we'll do here. Sue, on the other hand, she's traveling west, and that's at 50 miles per hour. The rate's 50. And the amount of time traveled for Sue, well, it says she leaves at the same time, and so they're leaving at the same time in opposite directions, but they will be traveling the same amount of time. So Sue's time is the same as Jerry's time, and we call Jerry's time x, so Sue's time will also be x, same quantity. All right, well, that's our first two columns there. Now what we need to do is fill in this distance column. Well, for the distance, remember that there is a formula for distance. Perhaps you're familiar with it. It is distance equals rate times time. And that's a formula we'll use here a lot. Distance is rate times time. So for each row here, for the distance, we're going to take the rate times the time. So in Jerry's case, we'll have 40 times x, 40x. And then in Sue's case, we've got Sue's rate 50 times x. So the distance, rate times time, will be 50x. Alright, so that basically completes our table. Now let's think about our equation, see if we can get an equation here out of this. What we also know is that we want them to be 350 miles apart. So in other words, we want the total distance to be 350 miles apart. Well, if we draw out that sort of scenario, here's let's say this is Jerry's and Sue's house right here. And Jerry, well, he's traveling east. And then Sue, well, she's traveling west, a certain amount of distance. So here's Jerry's distance. And here's Sue's. What we want is that total distance to be 350. Well, we can kind of see the equation shaping up. If we take and add together Jerry's distance and Sue's distance, that's going to have to equal the 350 miles. So we're going to add Sue's distance to Jerry's. Well, what do we have for Jerry's distance? Well, Jerry's distance, we've got an expression, is 40x. For Sue's distance, we got 50x. So there's our equation. We're going to take the 40x plus Sue's distance, 50x, Jerry's distance plus Sue's distance, and that's going to equal the 350 miles. All right. There's our equation. Now we can get our solution here. Solve for x. 50x plus 40x, that's 90x. So that equals 350. Divide by 90. And that'll get us x equals, reduce there by 10. 35 over 9. We are talking hours. Not quite 4 hours if you round that to a decimal. Let's see, 35 divided by 9. Okay, so it's 3.888 repeating, about 3.9 hours. Not quite 4 hours. Now, what we might want to think there is think about, well, that's part A. How many hours are they? If you convert that to mixed number, that's 3 8/9 hours. So that's part A's answer. Part B. In how many minutes will they be 350 miles apart? Well, to convert hours over to minutes, the number of hours is, you multiply that by 60, and that will give you your minutes. So let's take the 35/9 hours, 3.89 hours, whatever. Multiply that by 60, and we do that. Type that in. That's going to give us 233.33 repeating minutes. All right, so that's 233 minutes. The nearest minute, 233 minutes. All right, so that answers number 1. Let's see what else we've got here. Number 2. On a different day, Sue is to take a business trip and leaves at 9 a.m. She averages 54 miles per hour. 20 minutes later, though, Jerry realizes Sue forgot her briefcase and leaves to catch her, averaging 64 miles per hour. So he will catch her because he's going a little bit faster there, but he leaves later. How many minutes does it take Jerry to catch Sue? All right. Well, we can start this same way as before. Nice little table. All right, so in this case, we've got Sue who leaves first. So let's put her name there first, and then Jerry leaves second. Well, we are going to do the same columns here in our table. Let's call it the RTD table. Rate, time, and distance. That's what we need in this case. All right, so Sue's rate, we do know that's 54. And Jerry's rate, that's 64. All right, let's talk about the times, though. Sue's time, we don't know. We're going to call that x. Well, let's note here that Jerry's time, well, it's not the same as Sue's time. He actually leaves later, so Jerry's time is going to be a little bit different. Now, let's think about it. If Jerry leaves later, the amount of time he will have traveled will be less. So we're going to take x, Sue's time, and subtract a little bit from that. Now let's don't jump the gun though and say, well, he leaves 20 minutes later, so it's x minus 20. Now note that our time, since our rate is in miles per hour, our time is in hours. Not minutes. So if I put x minus 20 right there, that's x minus 20 hours. Now I want 20 minutes in terms of an hour. So what does 20 minutes equal in hours? Well, if you take the minutes and divide by 60, that gets you 1/3. 1/3 of an hour is what 20 minutes is. So that's what we subtract here. X minus 1/3, where 1/3 is 1/3 of an hour. Okay? Alright, so that's our time column. A little bit of a twist on it. On the distance, well, distance, remember, we're going to use the fact that distance is rate times time, so I'm going to take the rate in each case times the time. So the top one, I've got 54 times x, 54x. On the second one, though, I've got 64 times x minus 1/3. All right. Now, we've also got something different in this one because we want for Jerry to catch Sue. All right. So here's what we want. Sue's going to take off, and she's going to be traveling whatever direction, and then Jerry's going to take off a little bit later. He's going to run a little bit faster, so he's going to at some point catch Sue. They're going to have gone the same distances, in other words. Jerry's distance and Sue's distances, we want those to be equal. That's what will happen when Jerry catches Sue. So the two distances are the same. Well, that suggests our little equation. In this case, I want Sue's distance to equal Jerry's distance, or vice versa. So I want the two distances, so this is the distance of Sue, to equal Jerry's distance. So I'm going to set those two expressions, the 54x, Sue's distance, equal to Jerry's distance, 64 times x minus 1/3. That's our equation. So when I have a scenario where we want one person to catch another person, or one plane to catch another plane, or whatever, you set the two distances equal. Don't add them like we did in number 1. We're going to set them equal. All right, well, how do we solve that? Well, we distribute the 64 here, right? 64 times x, 64 times 1/3. See, 64 times 1/3, over here to note that. Yeah, that's going to be 64 over 1 times 1/3. 64 over 3, in other words. Oops. Get rid of that. So that's going to be 64 over 3. 64 divided by 3, I guess could round off if you wanted to, but it's 21.3 repeating. Something like that. All right. So now, just solving out for x, we subtract 64x to get the x's on the one side there. And so that'll make on the left side 54x minus 64x is negative 10x. And then on the left side, the 64's go out, so we have a negative 21.33. Might need to move over here just a little bit. So we have negative 10x equal a negative 21.33. Divide by negative 10. That'll give me my x. And that'll be a 2.133 hours. All right. Now, do we answer the question? How many minutes does it take Jerry to catch Sue? Well, no, we haven't answered the question. We want Jerry's time. So Jerry's time is x minus a third. Go back to our chart here. Jerry's time, yeah, it's x minus a third right there. So when they take that 2.133 and minus 1/3 from it, do that on my calculator here. .7996, so 1.8 hours. Yeah, but I want the number of minutes. How do I convert that to minutes? Well, you take the number of hours times 60, and that'll give you minutes. 1.8 times 60 is 108 minutes. Jerry's time to catch Sue. 108 minutes. All right?